in this unit, there are a lot of instances where there isn't necessarily math happening. A lot of it is concepts. Like, do you recognize a certain shape based on certain properties? So you need to make sure you have those properties on your study sheet somehow, okay? If you have your formula sheet handy, I'll just show you some of the formulas that you hone into. Did you get the formula sheets already? The yellow one? So if you have your formula sheets, I'll just tell you some of the ones that we will focus on in this unit. And just focus there. Okay, so on this first page, if you start here, sum of interior angles in a polygon, measure of interior angle, like all of these here, starting from there, pertain to this unit, okay? So those formulas are all given to you, and we will not do that right away, but we'll get to it later on. So formula sheet, when it comes to formulas, this is it, okay? And but it is linked with trig, and you'll see that in a bit, that trig pops up. So properties of, what are we, October? I'm just going to date this for myself so I recognize that this, okay? So we're going to do a lot of it will be reviewed today, but it's crucial when diving into this unit that you're very familiar with the basics, okay? So working with right triangles, we're going to do a lot of that now, right? Right triangles, what that means is if you want to have an arrow, it is a triangle that has a box like that or has a 90-degree angle there. Okay, so if that's the case, we can use the Pythagorean theorem. If you only know two sides, right, and you want to know the third side, then you want to use the Pythagorean theorem. Okay? If we go back to this triangle, there's one side in particular that we're very interested in, and it's always across the 90. If you go across the 90, we call it the hypotenuse. And I know I reviewed this the first week back, right? So this is the hypotenuse. We call the other sides are referred to as legs, right? So you have leg 1 and leg 2 if you want to talk about it that way. But this is always the longest side. It's the longest, it's across from the 90. So that's that. Okay. So two cases, right? If the hypotenuse is unknown, then it's just c squared is equal to a squared plus b squared. That's how we would want to set it up. And then the next step would be c is equal to square root of a squared plus b squared. This is really where I want to get to. I want you to be able to do this almost right away. If you want your hypotenuse to take the square root of the sum of the squares, right? And I will make this, I will highlight the plus in there. The second case is one of the legs unknown. One of the legs is unknown, then we would do it this way. A squared is equal to C squared minus B squared. So if you just wanted to find A, which in this case is a leg here, you take square root of C squared minus B squared. And there's the minus that I'm going to highlight. And of course, B is also a leg, right? So you could write the same thing as this. B is equal to square root of C squared minus A squared. You can write it the same way, but notice that C squared is always first. This is your hypotenuse. And you subtract the other leg from it. So we will say or here. Right? And right beside you'll say this or that. Okay? So those are your two cases. And maybe I'll just make a note that it doesn't matter what the letter is. You want to make sure the hypotenuse is there. Right? And this is a leg here. If you remember that if you want to find one of the legs, you take the hypotenuse and you subtract the other side, but always squaring them. And then the last step is to square root your answer. You kind of work your way out. Okay. There's two folks that joined. Can you just type here in the chat if you joined after I took the attendance? It was 17 last time I did the attendance. So Angelito, okay. And just update the ones that are here. Those are the ones that are really straight. We're good. All right, let's move on. Hopefully that gave you enough time to catch up your notes. Adrian, okay, right on. We are, if you join chapter 5, so find this booklet right here. And that's how we're on, okay? We're slowly moving through that. Let's move on to the next page here. And if you were paying attention in grade 11 and grade 10, and if you have a good memory, this should ring a bell. Do you remember Sohcahtoa? Yeah? I don't want you to think of it anymore. Just scratch it. Because students mix up Sohcahtoa with Sine Log Cosine Law all the time. And so I just decided not to review Sohcahtoa, right? If you're ever going into plumbing or electrical, anything like that, where you need to work with angles, you're probably going to go back to Sohcahtoa. But Sine Log Cosine Law always work, no matter what industry you're in. It works with right triangles or oblique, which are non-right triangles, okay? So we're going to find the length of missing side A. So can you go ahead and do that on your own? I think you're fairly capable of doing that. Actually, there's going to be 3 examples there. I'll do this one. I'll do this one with you. So we're on page 175. We're looking at this triangle. 2 out of the 3 sides are known. Okay, so we know 2 sides. Use Pythagorean Theorem. Okay, that's the first observation I'm going to make there. You can't use sine law. You can't really use cosine law. This one is faster to use Pythagorean theorem. So this is my hypotenuse, by the way. And notice how they've called it A. They've done that on purpose. Okay, but you're missing your hypotenuse, right? So that would be the first case that we just did on the first page. So you write down, all you need to remember really is that you'll be adding the legs together. If you remember that, right, you want to know this one, you would have to add because it's the longest out of the three. So another step would be to just show this. I'm okay if you go straight to this line, by the way. If you go straight here, you know it's going to be added, and you always square everything and then square root it. So if you run that through, you get 146/12. Don't round here. Whatever you get, that's what you write down. If you don't want to include all decimals, at least 4 decimals. Okay, because if you round to 2 here and then round to 2 again, you'll be losing marks. Okay, so A is equal to 12.09 centimeters. Clearly always indicate your final answer. You can box, circle, underline, use a sentence. I think somebody else joined. Can you just type here on the chat? I'm just looking at the number of people. Just type here and then I know you're there. Okay. And we are doing chapter 5 now, so go get your booklet, chapter 5 booklet. We're on page 175. I'll give you another example here. We're going to have the 90 up here. Okay. And we're going to call this 178.5 inches. We're going to call this 63.8 inches. And let's go DEF. Okay, I went DEF around. So if you have the angles labeled, then this should be lowercase e according to that. If you want to call it X, I really don't care about that. Okay, Nicholas, got it. Oh, Jonathan and Nicholas. Jonathan, you know you were supposed to be here though, right? But I'll make a note. All right. So this one, missing a leg, right? Because this is the hypotenuse here. Therefore, that must be one of the legs. So what we'll do is we'll do the shortcut. E, just E, side E is going to be the square root of, you grab the longest side, you square it, then you go minus the other leg, okay? Square it. Make sure everything is under the square root. And if you have a calculator with 2 lines like mine, okay, I'll make it appear here, 178.5 x2 minus 63.8 squared, you get that. Okay? And then you square root your answer. So it's 166.7. It's 71 actually. So in 3 lines I've answered this question. Okay? And now I'm going to ask you to do 1A to C, okay? Do page 176, 1A to C, right? Do that now, practice. C is a little tricky, but you should be able to do that at this point. So take a few moments. I'll pause the recording. We'll do 5 minutes. So let's go to 176 and correct it quickly. So again, these booklets are a backbone. So I always add stuff and we jump sometimes. Okay, so here we're missing the hypotenuse. So this will be an adding situation, right? You take the square root of that. You get 7,068.25, and then your final answer is 84.07 centimeters. Okay, so you got that there. Next question. This is a leg that you're missing. This was your hypotenuse you were missing. So you're missing a leg, so you would have to subtract, and order matters, right? It's the bigger one minus the smaller one. So no decimals in this case. So it's 7760 is your answer there. And always check, right? It should be shorter than the hypotenuse. If it isn't, you made a mistake, okay? And then next, whenever you have two triangles, you want, right? Which one do you start with? It's the one you know most of. So you would start here and then you would move over to there. So we will find side X here. And for this triangle, X is a leg, okay? So X would be square root of, this is my hypotenuse, minus 68.4 squared. X is square root of 331.69. X is 57.72. So we're not done yet because that's not what they're after. That's part of the work. Okay, so now we move over. So this was in triangle 1. Now we're going to move over to triangle 2. And here we are missing the hypotenuse. We now know what this is. We're missing that. So in this case, it'll be adding those two, right? It'll be 5772 squared plus 46.9 squared. P is square root of 5531.2084. Just write them all down, okay? You don't. 37 centimeters. That's what they're after. That's their final answer. So always start with the triangle you know most of and then move over to the second one. So go ahead and write that down. Next page. Okay, so this will take you back to sine log cosine law, okay? In this case, you know a side and an angle, but in fact, you actually know two angles, right? So whenever there's an angle mixed in, like one other angle other than the 90, use sine law or cosine law for that matter. Okay, so do you have a pair here? You have 41, you have 90. You can find this, right? It's supposed to add up to 180. So 180 minus 90, you're down to 90. So it'll be 90 minus 41. That gives you this angle here. It'll be 90. So 180 minus 90 minus 41. Okay. And that gives you 49. So this angle here is 49 degrees. And there you have a pair. Now use sine law. So if there's an angle now mixed in, okay, you want to use sine law, cosine law. Okay, so here we go. We're going to use sine of 49 over 4.2. That's our pair. And they want side W. That's across from this. So we take sine of 90 over W. And so you would cross multiply here, 4.2. I don't know if anybody remembers what sine of 90 is. It is always 1. Basically, like you putting down 1 there. So that ends up being 5.57 meters. You could not have used Pythagorean theorem there because you need at least 2 out of the 3 sides. Okay. I don't know if you want to make a note of that. Somewhere up here, can't use Pythagorean theorem because I don't know 2 out of the 3 sides. Next, calculate the angle. So we found a side. Now they're asking us to find the angle. So they want this angle here. Do you have a pair? Yes, you do. Okay. Sine law. So you'll find that sine of 90, which is this one, over 3.9 is equal to sine of E over 2.8. And there you cross multiply this way. Don't drop the sign. That's your line. Angle E, it will be sine inverse of this, which is 0.7179, and it keeps going. Angle E is 45.89 degrees. Could you now find angle F? Absolutely. Extension. Angle F. It's a right triangle, so it'd be 180 minus 90 minus 45.89. Right? So it would be 44.11 degrees. Just an extension, right? You could now find out a lot more. Could you have used the Pythagorean theorem to find the side F here? Yes, you could. Could you have used sine law to find side F? Yes, you could, right? So as long as it's a right triangle, Pythagorean theorem is now an added tool you can use. Okay, so make sure you write this down. And then I'll ask you to try this now. So do page 178. Questions 2 and 3, 2 to 3. Okay, so there's 2 ABC and there's 3 ABC. So there's one question that goes on to 79. Okay, so give that a try. Solve for the length of side X in each scenario. And 3 is asking for angles. So It'll take a little longer. So if you look up on your screen, I'll just slowly start working through it. So look at the first three here. Question 2, right? A, B, and C. Write down the answers at least if you haven't finished it. And you know you have to go back and check, even though I'm assuming that at this point that this shouldn't be an issue anymore. Okay? What about 3 though? Question 3, that might have been a little bit more challenging, right? Like how do you even start? Don't see a pair anywhere. Don't know how I can get a pair. But you can find this side right here. If you find that side, then you can use sine law there. So we can use the Pythagorean theorem to do that. We know we're going to add the legs because we're trying to find the hypotenuse, right? So the square root of that, I don't have this in my notes. I have the final answer, so it's 94.9. So x is going to be 9.74 meters. Okay, so now that you have this 9.74, you have a pair. Okay, so sine of 90 over 9.74 is equal to sine of A over 5.1. And sine of A is 5.1 times sine of 90 over 9.74. And so angle A is going to be sine inverse of 0.5236. Keeps going. Angle A is 31.57. So you have to be a bit creative sometimes to get these done. But that's how you do it, right? So here they want this. You do have a pair already. Okay, so sine of 90 over 25.8, sine of A over 17.3. Sine of A is 17.3 times sine of 90 over 25.8. I'll continue over here. Angle A is sine inverse of 0.67, keeps going. Angle A is 42.11 degrees. All right. So it's a little messy here. So what we'll do is kind of cut it off, right? This is the work for B and this is the work for A. Good? All right. Let's keep going. And for this question, we do have a pair. We have a pair, so we know we can get started with sine law. But if they're asking for angle A, sorry, you can see that. If they're asking for angle A, then we need to know the side. So first of all, side A, if you do Pythagorean theorem, that's 129.5 squared minus 80.4, right? Because you have to realize that it's one of the legs that you need, so you would have to subtract. A is going to be 101.52 millimeters. Okay, so now you can use that. You can use sine of 90 over 129.5 is equal to sine of A over 101.52. Sine of A is cross multiplying 101.52. Sine of 90 divided by 129.5. Angle A is sine inverse of point. Oh, I don't have that. .78 keeps going. So angle A is 5162. There it is. So a combination of Pythagorean theorem and sine law allowed us to do this. Okay. You cannot use Pythagoras if you don't have that. Okay, that's something very important. Some students want to use it on an oblique. You can't do that. Okay. Okay. We're gonna skip ones to. At this point here, I'm gonna ask you to go to what page is that? 181. Okay. Go to page 181 for notes. Okay. We're going to add some notes. I have a blank page in there. So go to that and then I'll give you some notes to write down. Okay. Everybody got that? Page 181 at home? Then we're going to come back to this. Okay. And I'm just going to give you a little bit at a time. Properties of triangles. Okay. Maybe if you can copy that, then I'll jump in. Let me just fold this so that it stays flat. So page 181. If you're missing that, copy this to page 181. And I summarize it, right? The first one says, if all angles are different, then all sides are different also. And we call it a scalene triangle. And look at the markings, right? Every single marking is different on all three sides. And the angles would also be different for that same reason. I'm going to turn off the front. And also, those of you that are at home, if you come in, there are handouts for this unit that you need to take. There's a rack with papers right at the middle center of this room. So you just come in, and if you don't recognize those handouts, you take one of each. The second point is that two equivalent angles on a triangle means that equivalent means the same, okay? Same measure. It's like equal, right? Equivalent, two equivalent angles means is the same thing as saying two equivalent sides. Okay, so if you have a triangle and two angles are the same, you know that there's going to be two sides opposite those angles that you can guarantee they're the same as well. So we call it an isosceles triangle. Okay. But watch the note there. The equivalent sides have equivalent angles across up from them. Okay. So it's not just any two, they have to be across each other. There are some formulas. So if the other angle is known, what I mean by the other is the one that isn't equivalent, right? If you know that one, you can actually find B and C by just using this formula, right? 180 minus the one you know, and you split that in half, okay? Maybe what I will say on the formula here is that the top has to be, it's in brackets, right? So you do the top first, and then you divide by 2. And we know that B and C are the same. So when you're finding B, you're actually finding C as well, right? By using this formula. On the other hand, if the equivalent angles are known, right, you can just go to find that other angle, you would just go 180 minus 2B or 2A. It doesn't matter because they are the same measure. They have the same measure. So isosceles is kind of a bigger component. And the last one, my writing is bigger than most, so you can probably fit this in 3/4 or half a page. But I make sure that you can read it, right? three equivalent sides means you have three equivalent angles. This is called an equilateral triangle. No surprise there. I'm sure you've all heard and know about it. Equilateral triangle. All angles measure 60 degrees, always. There's no exception, regardless of the size, okay? You could have a small equilateral triangle, a large, it doesn't matter, it's always 60 degrees. And the fact is the property still remains the same. It's the angles across these three known sides that are all equal that will make sure that all angles are also the same. Okay, so these markings are very important to recognize them. They give away a lot of information. Okay. And write this down for now, but all three properties go both ways. And I'll explain that in a bit. Okay. And I know I flipped this one on you. I said I start talking about sides and then angles, even though up above it was all angles first and sides second. It doesn't matter. If you know this part, like something about the angles, you know that this side is true as well. But if you had only information about the sides, you know the information about the angles as well. So you can, if you know one of them, you will know the other. Okay? So I know that at home it takes a little longer to copy this down. So I'm going to go up and just show a bit more there. And then we're going to go back to 179. Okay, so this is very important for you to know this because oftentimes I just assume you know, and then I give you questions like that with markings and you don't know, like I ask you to name them and you don't know how to name them, right? And so I make sure you have this available. So if you need to have this on your study sheet, that's something you need to consider, okay? In here, we're all done writing down. I'll give you some extra time at home. So I'm going to now move over to 179. So we're going to continue highlighting a few things, okay? So this is important for naming. You're going to have to be able to name triangles, okay? Based on their angles and based on their sizes, okay? The side lengths. So characteristics of a triangle. What properties describe a triangle? Has three sides, closed figure. The sum of interior angles 180. So I don't think this is anything that is very new here. But we're just going to highlight it anyways. Triangles can be classified, right? This is important. Triangles can be classified by their side lengths or by the sizes of the interior angles. Okay, so you do side lengths and angles, right? Those are the two things that we classify them by. So classification is naming them. So every triangle should have two names. So it's like a first name and a last name. Every triangle will have a first and a last name, okay? Except for equilateral. Okay, so every triangle will fit one of these three categories. right, in terms of their angles. So I hope you just know that, right? It's either acute, it's right, or it's obtuse, right? If it has less than 90, if all triangles are less than 90, if it has a 90, right? If it's greater than 90, it's obtuse. So that's how easy that is. That won't be hard to determine. So acute, right, or obtuse based on their angles for sure, right? Just so you know, as soon as you have one angle that's bigger than 90, it is obtuse automatically. As soon as you have a right, it is. So if they're all less than 90, then you know it's acute, okay? Next page. This is by their side length, okay? Side length. There's equilateral, isosceles, scalene. We just talked about it. So I don't know if you want to just that. And scalene, right? All different lengths, right? Different lengths. No angles are equal measure. Okay. So you want to refer back to, so basically this triangle here, if it is a scalene, this would be one size, different size, different size, right? And we know that the angles would all be different as well. So you can go and do the markings, right? Just make sure they all have different markings. You could have 4 or 5 crossing lines if you need to, okay? But this had all three the same. Therefore, these two angles, right? All three same size, so all three angles are the same. What books a lot of times do, they'll to distinguish the angles, they'll do one here, they will do two here. Actually, this should have one because it's across the one. This should have three like this because it's across the three, and this should have two because it's across from the side that's marked with 2. So now you're also saying that all three angles are different. Okay, that's how you distinguish the angles. Okay, so we're going to practice going back a little bit. Okay, so we're on 180. We're going to go back to 178 and practice labeling them there. 178, that is. Classify triangles on page 178. That's what we're going to do now. We're going to go classify back to 178 because they start right away with a heavy duty example. I want you to just know the basics. Let's see how we can do that. So remember, they always have a first and a last name. So let's go to 178. And let's see. And by the way, you have acute, right, obtuse to choose from in terms of the angles. And you have scalene, equilateral, and what's the other one? Isosceles. By the way, all equilateral triangles are acute. Does that make sense? Because they're always 60, right? So we don't need to go acute equilateral. If it's an equilateral, we'll just go equilateral. Okay, so here, this one we can for sure say, so every single one of them, these will have two names, right? This will be right. We know that because of this, okay? That little thing there tells us the right. What goes in here? Is this a scalene? Is this an isosceles? How do we know? It's a scalene, but I want you to know why, okay? Because Watch this. If this is 90 and this is 27, then we know this is going to be something else, right? We know that this angle is going to be different. So because I know two angles, this one here will be what? 90 minus 30 will be 60, so 63. Because, and I just look at the angles. Remember, you can look at it from both sides. All three sides or all three angles. I look at all three angles are different, so I know this is a scalene. And you're like, well, didn't we just label the angles here? Yes, but this one, all you need to look at is it acute, right, or obtuse. To find out the side lengths, I can also look at the angles to get me there. And I'll say that all angles different. That's all I'm going to say there. In case you're wondering, like, how did you come up with that? I knew 2 out of the 3, so now I know that, right? So over here, we know it's right because of that. And actually, we already did the work here. This is 49. So we know all 3 angles are different. So that's a scalene as well. So this will be a little boring because technically here they didn't expect you to know this yet, so they're all right. This is a right here. So right. And notice that 62, 28, and 90, they're all different. So this is scalene as well. What about this one? I will name this over here on this side. We know this is right. We don't know enough yet. Oh, actually we do. Sorry. I was just going to say we already solved this, but we know that all 3 sides are different. So this is a scalene as well. And I know this is repetitive, but I'm walking you through the criteria that what am I looking for? Okay. Here. So they're all right. That's not the problem. It's this part. What would you say here on this triangle? This is a 90. I did the work and I figured out this is 42. So I know unless this is 45, right? If this is 45, we know this is 45. That's the only option I have for isosceles. So this is also scalene because I know that this angle will be 47.89, right? So I know they're all different. Okay. So let's go and do that one that is a little harder. Maybe not for you, but so let's go to 180 again. It's underneath the tables we were given. Okay, use the following diagram to answer the question below. What is the side length of BC? So this is a side BC. That means that it's from B to C that they're wondering about. Right? What is this? Okay. If you see this triangle here, this is a right triangle. So we're going to find x and then multiply it by 2 to get the whole stretch because this is the same as that. How do we know that? Because this is an isosceles triangle. If you split an isosceles, you get exactly 2 same halves. So x is going to be square root of 20 squared minus 16 squared. X is going to be oh, I did it a different way last time. Okay. I will stop it here, and I will undo this next time. So you can actually already erase it. It can be done using Pythagorean Theorem, but I won't. Okay, because we can use one of the laws. All right, thank you guys. You can log off at home. Make sure you log on every day. Okay. See ya.